Hello and welcome back to our calculus videos. This time we will talk about an integration technique called integration by parts. Right, so recall that if we have a product of two functions, so two functions multiplied, then if you want to take the integral, you have to be a little bit careful. So, for example, let's say we want to find the antiderivative of x times sine x dx. So you have a product of two functions. To find the antiderivative, it's not very simple. In particular, you cannot just take the antiderivative one by one. You cannot say that the antiderivative of x is x squared over 2, and the antiderivative of sine x is negative cosine x, and sit back and relax. So this is not going to work. This is very similar. The problem is very similar to the problem when you're trying to find the derivative of a product of two functions. If you want to find the derivative of x times sine x, then again you cannot take the derivative one by one. You can't do that. In fact, if you remember, to find the derivative of the product of two functions, we use the product rule, right? Unfortunately, for the integral, there is no product rule, okay? So there are other methods that we can try to solve this situation. One of them is substitution method. So if you have a product of two functions, or also if you have a ratio of two functions, so two functions divided, you can try the substitution method to solve the problem, but it doesn't always work. For instance, let's say we want to find the antiderivative of x times e to the x. The substitution method wouldn't work in this case. Fortunately, we have another very powerful method that helps us to solve antiderivatives of very big class of functions, which is called integration by parts. So let me now talk about the integration by parts. So the formula for the integration by parts is the following. Let's say we have an integral of the form u dv. So if you have an integral of the form u dv, then you can rewrite it as u times v minus the integral v times du. So the idea is that if you have an integral u dv, you can rewrite it this way, and hopefully when you get another integral v du, this integral is easy to solve. So let me demonstrate how this works with an example. So let's say we want to find the antiderivative of x times ex. Again, you have a product of two functions. We have to be very careful. You can try substitution method. It's not going to work. So let's try the integration by parts formula. Let me put this formula in the box for you. So the first thing you want to do is you want to decide which part of this integral is going to be u and which part of the integral will be dv. Figuring out which part is u, which part is dv will come with experience, will come with intuition. I will say a little bit more about how I'll give you some hints about it later on, but right now, just go with me. What I will do here, I will choose x to be u, and ex dx I'm going to define as dv. All right, so we define what is u, we define what's dv. Now, using u and dv, we need to calculate the remaining parts of the formula. So if u equals x, then du, which means derivative, would be equal to 1 dx. And then we decided dv is ex dx. So then taking antiderivative, well, the antiderivative of e to the x is just e to the x, right? So here we're doing antiderivative. So now using u, du, dv, and v, we can substitute everything into this formula and see what we get. Right, so first we have to do u times v. So u times v, x times e to the x, minus the integral v times du. So here's v, and here's du. So we'll get e to the x times 1 dx. All right, so now we still have another integral here, but luckily this integral is easier to solve than the original one, because here all we have is just e to the x, and the integral of e to the x is e to the x. So first copy this part, and then we say the integral of e to the x is just e to the x. Okay, so one more time, the steps are very simple. First you have to decide which part of the integral will be u and which part of the integral will be dv. So then from u you calculate du, from dv you calculate v, and then you plug in these 4 values into the right hand side, and then try to finish solving the problem. Let's do another example. So before I do another example, let me give you one advice on how to choose u dv. So one advice is that if you have an integral of the form, and this happens quite often, if you have integral of the form x to the n times fx, then it's often going to work very well if you choose this xn part as your u, and then the rest to choose as the dv. Okay, so I'm not saying this is always going to work, but it's often a good idea to define xn as u and then the rest as dv. Okay, so now let's do another example. Let's say we want to calculate the integral x squared times e to the 3x dx. So again, you have a multiplication of 2 functions. You have to be careful. You can try the substitution method. It's not going to work, so then you can try the integration by parts. So the first step, we need to define what's u. So u will be x squared, and then the rest will be dv. Next step, from u, we have to calculate du. This is again derivative. So what's the derivative here? We get 2x dx. And then from dv, which is e to the 3x dx, we'll calculate v. And here we're doing anti-derivative. Anti-derivative. So what's the antiderivative of e to the 3x? Well, it's 1 over 3 e to the 3x. So here what I did is I used this little formula. If you have e to the power kx plus c, then the antiderivative is e to the kx plus c. So it's essentially the same thing, except you have to divide by k. And k here represents the coefficient of x. So looking over here, the k in our example is 3, so that's why the antiderivative is 1 over 3 to the 3x, using this formula. All right, so we found du, we found v. Now let's put everything into the formula for integration by parts. So according to the formula, we have to do u times v. So that will give us x squared times 1 over 3 e to the 3x. And then minus the integral of v du. v du. So that would be 1 over 3 e to the 3x times du 2x dx. Okay, so now let me erase this so we can continue. Let me rewrite a little bit what we have down here. So I'm not going to do anything, I'm just going to rewrite it to make it look a little nicer. So the first part I will write as 1 over 3 x squared e to the 3x. And the second part, I will take 1 over 3 and 2 outside the integral. So we'll have negative 2 over 3. And what is left inside? We have x times e to the 3x dx. All right. Now, let's look at our new integral. Our new integral, again, contains a product of two functions, x times e to the 3x. Okay, this guy. To solve this integral, again, we'll have to use the integration by parts. Okay, it's not, as straightforward as it was in the previous example. If we just had the integral of e to the 3x, then we could have gotten the answer right away. But we have here x times e to the 3x. So to get the answer here, we have to use integration by parts one more time. So let's do that. Since we're running out of space, or maybe I'll just use the top. Let's see. To keep it all on the same side of the board, I'll use the top. So what I'm going to do is I'm going to solve this integral. Let's define this part as u and the rest as dv. So we'll have here u equals x. So that means du, the derivative would be 1 dx. And then we said dv equals e to the 3x. So the antiderivative is again 1 over 3 e to the 3x. Okay, so what we will do is we will use these four values to replace the new integral. So let's continue with this example. So suppose we have equal sign here. I'm going to continue with the equal sign here. Right, so what we have here is 1 over 3 x squared e to the 3x in the beginning minus 2 over 3. And now the integral inside the brackets, I will calculate using the integration by parts formula in these four terms. So according to the formula, we do u times v. So we will have x times 1 over 3 e to the 3x minus the integral of v du. So v is 1 over 3 e to the 3x, and du is just 1 dx. Okay, so now let's see what happens. Copy, copy, copy. Not too exciting. Okay, so finally we get to the final stage. Now this integral, put another pair of brackets here. We can actually calculate directly. 1 over 3 is just a constant, so we take it out. We don't have to touch it. And the integral of e to the 3x is 1 over 3 e to the 3x. Okay, so that basically pretty much finishes our job. If you really want, and you probably should, maybe go through one more step to simplify things. You want to multiply 2 over 3 by everything inside the brackets. So you'll get 2 over 9, right? Multiplying these two, x e to the 3x. And then multiplying here, again, you get 2 over 9, but now with a plus sign. So wait, 2 over 9, oh, we have another 1 over 3, so I better fix this. 2 over 27, e to the 3x. Okay, so you see that in this example, we used integration by parts twice. And then if you can imagine that if I have x to the power 3 in here, you might have to do integration by parts 3 times. And you can see this is getting really long and complicated. So there is a very nifty technique that allows you to do the integration by parts very quickly. Okay, so let me just quickly show you how that technique works. So let's do this example again, but using a different method. I don't know if there's any formal name for this method. I just call it the table method. Okay. So the way the table method works is if you have a integral that you put in the form u dv, okay, then what you want to do is you want to create two columns. In the first column, you put u, and then in the second column, you put your dv. And then what you want to do is you want to, in the first column, you want to take the derivatives as many times as you need until you reach 0. And then in the first column, you take antiderivatives as many times as you do on the left-hand side. And then you cross-multiply the terms, you get your answer. Okay? So let me illustrate this with an example, probably the best way to understand anything. So let's go back to our original example, which took us a while to solve, step by step, and use table method here. So if we use table method, we're going to put x, our u is x squared, so we're going to put the u here. And our dv is e to the 3x, so we put it here. And now I'm going to take the derivative on the left-hand side. So x squared gives us 2x, 2x gives us 2, and 2 gives us 0. On the right-hand side, I will do antiderivative. So I'll get 1 over 3 e to the 3x, 1 over 9 e to the 3x. And so my writing is very big. So 1 over 27 e to the 3x. And then the one that corresponds to 0 would be 1 over 81 e to the 3x. Okay, so this is the first row, second row, third row. Wait. So this is the first row, this is the second row. Okay, so I guess we don't need 1 over 81. So 1 over 27 e to the 3x. Okay, so now first row, second row, third row, fourth row. Now what you do is you draw diagonal arrows like this, diagonal arrows. And then we put signs starting with plus and then alternating. Plus, minus, plus, and then if you need, you can put another minus. And these arrows represent multiplication. So that means you have to multiply x squared with 1 over 3 e to the 3x, 2x with this, 2 with this. And that would be your final answer. So let's see if we do that, what happens. So we have a plus in front, so if you want, you can put a plus in front and do x squared times 1 over 3 e to the 3x. And then there's a minus, so you want to put a minus in front. 2x times 1 over 9 e to the 3x. And then plus 2 times 1 over 27 e to the 3x. And that's your final answer. So if you compare this answer with our answer from the first solution, you will see that they're exactly the same. This method was much shorter, right? So let's. So whenever you see, so usually my advice is, the table method works the best in a situation where you have xn times some function. Okay, so if you have a from my experience, table method works best in a case where you have x to the n times f of x. Okay, so let me do one more example to illustrate the formula. So let's say you want to do x cubed times sine of 2x dx. So you see you have xn times something. It's a good indication that the table method will work well. Okay, so let's try the table method. Okay, so in the table method, we're going to put x cubed in the derivative column, and we'll put sine of 2x in the antiderivative column. So let's take the derivative. We'll get 3x squared, 6x, 6, 0. Okay? And let's take antiderivative. So the antiderivative would be 1 over 2, I guess minus 1 over 2, cosine 2x. And then if I take antiderivative one more time, I'll get minus 1 over 4 sine of 2x. And if we do it one more time, we'll get 1 over 8 cosine 2x. And then finally, we'll do 1 over 16 sine 2x. So make sure I don't screw up again. Okay. All right. So now we draw diagonal arrows. Again, diagonal arrows, not straight arrows, but diagonal arrows. And starting with plus sign, we put alternating signs. And again, the arrows represent multiplication. So based on the table, our final answer would be x cubed times negative 1 over 2 cos 2x minus 3x squared times minus 1 over 4 sine 2x, and then plus 6x times 1 over 8, 1 over 8 cos 2x, and finally minus 6 times 1 over 16 sine 2x. Okay. So you can see that this method can be a lifesaver, because if you were to do this question using the traditional integration by parts approach, you'd have to do it 3 times, and even though it's not very difficult, it is very long because you have to keep copying these long equations. But here, it's all very compact and tight, and you get your answer right away. All right. So to wrap it all up, let me do one more example. Okay. So let's try to find the integral of ln t dt. So if you look at this integral, it's kind of hard to see how one would use either a substitution method or integration by parts. First of all, substitution method wouldn't work. And then even if you try the integration by parts, it's not very clear what part is u and what part is dv. Okay? So I'm going to go ahead and help you here. We're going to take ln t as u and dt as dv. Okay? Now let's try to apply the integration by parts formula and see if it works out. Okay, if u is ln t, then du, the derivative of ln t, is 1 over t. And actually, why don't I scoot over a little bit here to leave myself space. So if u equals ln t, du is 1 over t, and dv is dt. Now, if dv is dt, we can imagine that there's 1 standing in front of dt, right? Because 1 times dt is just dt, right? So this helps us to understand how you do the antiderivative, because the antiderivative of 1 is t. Okay, so now, then according to the formula, we have to write u times v. So ln t times t minus the integral of v du. So minus v times du. All right, and let's see what happens. Notice that t and 1 over t cancel, so you have just 1 in there. And what is the integral of 1 dt? It's just t. Okay. So there we go. I hope these examples help you to understand integration by parts a little better. The important thing, again, is to remember when you have a multiplication of two functions or a division of two functions, you have to be extremely careful, okay, and use techniques like substitution method or integration by parts. And then also we'll talk about some other ones later on. But you have to be very careful when you do questions involving a product of two functions or a ratio of two functions. All right.